We've been talking about predicting the future. And last time what we did was introduce a general approach to predicting the future motion of any system as long as we were able to calculate the net force on it. And often the net force we're interested in is going to be a function of where it is. So it's often a function of position. For example, the spring force we were calculating, the force on an object attached to a spring depended on where it was relative to the end of the spring. We'll see next week that the gravitational force depends on the relative position of two objects, except this approximate force near the surface of the Earth. As long as you can calculate a net force, which may depend on position, then you can use the momentum principle to update its momentum. You can use its new momentum to get a new position, and then you can just keep doing it again, and doing it again, and doing it again, and predict its motion on into the future. And we did one by hand, and then we let a computer do a few steps for us, but that's a game that always works. This is actually the most general approach. We'll see today that it's in some special situations it's possible to get an algebraic equation that'll tell you how you can calculate the position of something as a function of time. But in general, that's not the case. And in fact, it turns out that a system as simple as three objects, two planets and a star interacting gravitationally, there's no way to get a general algebraic solution. You can't get it using calculus. So in fact, this is the approach that one takes in that situation.